Hi, this is Fahad from NoodleSeed, and today I'm going to talk about Seed Specification Language and why the world needs a new language in the age of AI. You have business users who typically, when you go and talk to a user, will tell you what they want. They're not going to tell you how to implement it. So on one axis, we've got the declarative nature of what you have encoded in a language versus the imperative nature of how something is done in a language. The business user is going to be highly declarative. However, the perennial problem of dealing with natural language and business users who are not necessarily into the weeds of how things are going to be implemented is the fact that that description or that conversation is going to be highly ambiguous. A lot of work in software engineering goes into translating what a business user describes as what they want in an ambiguous language. However, it's very declarative in its nature, like what someone wants. A lot of time in software engineering is spent translating it into something that is less ambiguous, not as deterministic as computer languages, but a lot less ambiguous than what a normal person would describe. So we come down here a little bit. We also encode information a lot more about how things are done. So things like the architecture, the process flows, who does what level of permissions do people need, the sequence of events that are going to take place. There is some level of imperative description of what the user wants in a business requirements document. And then from here, once this is approved by a business user, developers can take and convert into more specific implementation languages, whether it's SQL, which is a bit more declarative, but highly obviously deterministic, or some sort of implementation language where you can describe how things are done. In a lot of work, this is typically the solutioning part, and then this is the development part down here. This is how typical software engineering is done in most business environments. Most business applications are built in this way. Let's look at what is happening in the world of AI these days. Large language models that are able to navigate. Let's say you have a tool, let's call it a helicopter or a high-speed aircraft or something that can navigate this entire space of languages. So a large language model is able to take something that is very ambiguous, that a normal user would describe, and find the path to convert it from a very natural language description into code that captures the intent of a business user. It may have been very ambiguous, and there may be a few different ways of implementing it, but a large language model is able to navigate this space. We also have a lot of tools, a lot of startups are working in this space where they're trying to convert directly to implementation languages, either here or any other language in this space. What is the problem with this? The fundamental problem with how almost every startup that I've seen is doing it in a very particular way. They're taking absolute natural language description. They're trying to work through some kind of agentic workflow where you take the business requirements, you come up with, let's say, a schema, rules, all sorts of things here, and then you take the schema and the rules and you try to generate SQL. But then what happened is, let's say you navigated to this point, it's not deterministic enough for it to translate very well here, but let's say even if it does, it translates very well to your database backend. And then you have another workflow that generates your JavaScript. This JavaScript may be internally coherent, this SQL may be internally coherent, but they may not be coherent with each other. It's not just two components that you need to generate. You might need to generate tons of components, maybe some in JavaScript, maybe some in Node, maybe some in Python, maybe some in various flavors of SQL. So there are all of these various workflows going back and forth from natural language to all sorts of things. And then what you need to do is typically, let's say you generate the SQL, you're going to generate the Python, you're going to include this and your entire business description or some representation of a business description, some summarization, something like that. But all of this space in between, this creates ambiguity. This is the problem where you have tools like Bolt and all sorts of code generation platforms that give you the code from natural language, but then there might be errors. Developers need to then go in, figure out what the error is, fix it, or have some sort of agentic workflow to try it again and again until that error is fixed. So there's a lot of engineering and hacking happening here to try to go around this, navigate this entire maze between a business user description of what they want and all sorts of languages down here where you need to produce different components with different level of complexity and different level of implementation detail. There is also the issue of when a language model is trying to generate, let's say, front-end code JavaScript. There are tons of frameworks it could use. Do you use Tailwind? Do you use something else? Do you use Material UI? Do you use different versions of different SDKs? All of that you are relying either on the language model or some very detailed descriptions of what you want the language model to do or how you want the language model to. This is the mess that all code generation tools are trying to solve. And we believe at NoodleSeed that if you take a step back and take a first principles approach, there is a better way of solving this problem. The problem is there is too much variability and flexibility in all of these different components. There are different targets, different deployment types, different SDKs, libraries, all of that. This space, to navigate the space of all of these deterministic computer languages, you should not be using AI to go in this direction, in this dimension here. But to navigate in this direction is where you introduce a lot of errors, a lot of possibilities and permutations and combinations, which are all correct in their own right, but then the components are not compatible with each other. What if there was a language completely declarative that contains absolutely no implementation details, but it is deterministic enough that from here to all kinds of other computer languages, you can deterministically compile or cross-compile from here to, let's say, SQL, or a backend in Python, or a front end in React, or any other language. Because this can be deterministic, this language does not exist. All of these languages were created and they came from different backgrounds, people working with browsers versus people working in scientific computing or low-level hardware or databases, or various backgrounds and reasons why different languages came into existence. Because AI is so new, there is no language that has specifically been created with certain qualities. We don't want too many tokens being wasted on implementation detail. We just want to, in minimum number of tokens, describe what a business user would want. And this is specific to the domain of business applications, where you have a web-based user interface, a database, and a backend which encodes business rules, logic, validation, permissions, etc. But there are only a very limited number of things that you need in a language like that that can convert a business user's ambiguous requirements into something that is completely deterministic, but still as declarative as what a business user would describe. Let's say we do this with AI, because AI is very good at navigating in this direction. But let's not make the AI navigate in this direction where we already have very good deterministic tools like code to go from anywhere in this space to anywhere in this space. Let's call it Seed Specification Language, because that's what I'm calling it. However, the whole idea is that it describes all of the specifications a business user wants for any business application, line of business application. And this is the seed from which all of the implementation can be generated or cross-compiled in all of these other languages. This needs to be done just once. You don't need to generate SQL, past that. It's a mess that people are trying to solve, a problem that should not exist. This is a far more superior way of solving this problem. In the next video, I shall show you the Seed Specification Language, what it looks like. We're developing it in open source. It's going to be an open source project. Anybody can view it. The tooling will be open source. We shall use it ourselves for our own products, where we are talking to a business user in natural language, but very quickly coming up with initially rapid prototypes. But our eventual goal is, if you're talking to a business user in natural language, the AI should really just be converting it very quickly in as few as possible tokens, completely declarative seed specification for what the user wants, and then very quickly cross-compile it to all sorts of components that you need for an end-to-end application. But once you have valid seed spec over here, there is no ambiguity converting seed spec to SQL or seed spec to front-end, back-end, workflows, integrations. All of the things that business applications need are going to be first-class citizens or primitives available within this language. And we're also going to make a standard library of common components that most business applications need as part of the language. The tooling will be open source as well. So this is the overall picture of why we think the world needs a new language in the age of AI, so that we can reliably, quickly, and at very low cost generate full-fledged, full-stack business applications using AI. Thank you.